Hi, and welcome back to another Build Fun Things video. Today we're going to solve Puzzle 2 from Advent of Code 2015. Day 2. I was told there would be no math. The elves are running low on wrapping paper, and so they need to submit an order for more. They have a list of the dimensions, length, width, and height of each present and only want to order exactly as much as they need. Skippy. Fortunately, every present is a box, a perfect right rectangular prism, which makes calculating the required wrapping paper for each gift a little easier. Find the surface area of the box, which is 2 times L times W plus 2 times width times height plus 2 times the height minus the length, multiple the length. The elves also need a little extra paper for each present, the area of the smallest side. Cool? That sounds like a good task. There are some examples that we can use for our test input again. Let's get started. So the first thing we'll need is our puzzle input. Let's open that up. It's a big giant list of dimensions. Very good. Select everything and add it to our input file. It's exactly 1000 lines long. So I started my skeleton implementation again, a day 02 class and a day 2 test case. Let's add the sample input. The sample data in the test case will fill now because we don't have a proper test case yet or proper implementation, but 2 times 3 times 4 should yield 58. And 1 times 1 times 10 should yield 43. So we'll create a function called calculate wrapping, which takes the length, the width, and the height. They're provided on a line-to-line basis, so we need to split up the line into each component. So we get a list of dimensions. For each of those dimensions we need to do a calculation. So let's break up the logic in processing the string that we get and the calculation itself. So within process entry we will break up the list. So for each present's dimensions we'll split it up into the parts, the length, the width, and the height. And we'll pass that to calculate wrapping, which will increment our order and will return the total order that we need. So now we have a list of strings that actually needs to be converted into integers to do some calculations with it. So let's use some Java 8 Lambda niceness. So we'll use the arrays package to stream every part of the string array, and we'll map to integer each item, and then we'll convert it into an integer array. One tricky thing about these calculations is that not only do we need to calculate the dimensions, but we also need to determine which of those is the smallest ones. So let's create an integer array called dimensions. We'll have the calculations on top right here. The times 2 part we cannot do yet because we need to first figure out which one is the smallest. We can do one neat little trick because the treatment of each dimension is the same. They will be times 2, but we need to know which one is the smallest. So we can use arrays to sort the dimension array, which will sort it in place. So this will mean that dimension 0 at this point will be the lowest value. So again, we can stream over the dimension array and we'll sum that value. So now we will basically do 2 times LW plus 2 times WH plus 2 times HL in one statement. And then we'll take the smallest value due to the sorted array. Of course, we don't need to do a map to int, we can just do a map. We hook up the process entry, which we'll call calculate wrapping. It filled with the index out of bounds because I accidentally put 2 instead of 3. Let's fix that and rerun our test case. Our test case for test sample input 1 succeeded, so the value that is right here as part of the test real input should actually be the input that we need to give to solve the puzzle. Yay! The elves are also running low on ribbon. A ribbon is all the same width, so they only have to worry about the length they need to order, which they would like again to be exact. Alright. The ribbon required to wrap a present is the shortest distance around its sides or the smallest perimeter of any one face. Each present also requires a bow made out of ribbon as well. The feet of ribbon required for the perfect bow is equal to the cubic feet of the volume of the present. Don't ask how they tie the bow, though they'll never tell. Alright, I guess the most important thing here is that it says the shortest distance is the shortest distance around its sides. So either length by height or width by height or width by length. So that's something to take into account. And then the cubic feet. All right. The samples say 2 times 3 times 4 requires 2 plus 2 plus 3 plus 3. Yeah, so those are the smallest ones here. Same here, smallest ones here. And then the cubic feet, which is just multiplying each element. So, okay, let's update our test case. Again, here we can take a copy of calculate wrapping and just call it calculate ribbon. So I made a copy of the function and removed all the dimension code, which basically leaves us with a conversion of the string array to an int array. I also changed the process entry to take an integer value to indicate which part it belongs to. Because the logic is the same, we just need to do a different calculation based on the part that is being run. So again, we need to find the lowest versions, lowest entries, so we can sort the array. Twice p0 plus twice p1, because 2 plus 2 plus 3 plus 3, same as twice 2 and plus twice 3, plus we do a p0 times p1 times p2. Our test case fails. Let's take a look at what the error has been. 14 and 15 looks like an off by 1. I made a typo. This should be a multiplication instead of a plus. Input for sample 2 succeeds, so we know our test cases are good. So the only value left that was returned was the actual output for our puzzle. Let's check if that's correct. Yay! We've solved puzzle 2. I will check this into the source code. Hope you enjoyed it, and I'll see you with the next puzzle. Bye bye!